there is a planet that should be the friendliest world in the solar system. It is almost exactly Earth's size, and it sits in the warm part of the neighborhood. For a long time, we imagined oceans there, maybe even jungles. Tonight, I want to take you to that planet and show you what we actually found, because the truth is stranger than any story we invented. It is a place that rains acid and crushes metal. Stay with me, and I will show you why Venus may be a quiet warning about Earth. If you enjoy these calm journeys, a like and a subscribe help. And tell me, where are you watching from and what time is it there? Let us begin somewhere comfortable. Close your eyes for just a moment and picture the solar system the way a child draws it. The sun in the center, warm and golden. The little rocky worlds gathered close to its fire. The giants out in the cold beyond. Now slide your attention inward, past Mars, past our own pale blue home, to the second planet from the Sunday. This is where we are going tonight, slowly, gently, with no rush at all. Of all the worlds in our family of planets, Venus is the one that should have welcomed us. If you were handed a list of measurements and nothing else, you would swear you were reading a description of Earth. Venus is almost exactly the same size as our planet. Its diameter is only a few hundred kilometers smaller. Its mass is about 4/5 of Earth's mass. Its gravity is so similar to ours that if you could somehow stand on its surface, you would feel nearly the same gentle pull on your body that you feel right now, sitting wherever you are. It is made of the same basic ingredients, rock and metal, a core and a mantle and a crust. It formed at the same time, from the same swirling disk of dust and gas that built the rest of us 4.5 billion years ago. And it is close. Venus is our nearest planetary neighbor. When the orbits line up, no other planet comes nearer to Earth. It sits just one step closer to the sun than we do, in what should be a comfortable, sunlit part of the neighborhood. So similar in size, so similar in weight, so close in space, and so close in age. For these reasons, people called it Earth's twin, our sister world. And for a very long time, we believed that beneath its soft and glowing veil, something wonderful might be waiting. Think about what they saw, those early watchers. Venus does not look threatening, it looks like a jewel. After the sun and the moon, it is the brightest natural object in our entire sky. You have almost certainly seen it without knowing. That brilliant, steady point of light hanging low in the west after the sun goes down, far too bright to be a star, too calm to be a plane, or the same light in the east before dawn, the last spark to fade as the morning blue comes up. The ancient world watched this light so closely that many cultures believed it was two different objects, an evening visitor and a morning visitor, never realizing they were following the very same wandering world. It is so bright for a reason, and that reason is the first quiet clue to everything that is wrong. Venus is wrapped, completely and permanently, in a thick layer of cloud. Not a few clouds drifting across a clear sky the way they do on Earth. Total cloud, a seamless, unbroken shell of pale yellow and white that covers every part of the planet at all times. Those clouds are extraordinarily good at reflecting sunlight. They bounce back most of the light that falls on them, and that reflected light is what makes Venus shine like a lamp in our sky. But it also means that for almost all of human history, those clouds were a closed door. We could see the outside of Venus glowing beautifully. We could not see one single thing beneath it. The surface was hidden, completely, perfectly hidden. And here is something gentle and human and a little bit lovely. When you cannot see a thing, you imagine it. For centuries, people looked at that bright, soft, cloud-wrapped world and let their hopes fill in the blank. The reasoning seemed sound. Clouds on Earth mean water. Water means moisture, rain, perhaps oceans. Venus was a little closer to the sun, so surely it would be warmer than Earth, maybe tropical. So a picture formed, and it was a beautiful picture. Many imagined Venus as a young, steaming, swampy world, a planet of warm seas and dripping jungles. Some pictured vast oceans rolling under those eternal clouds. Writers of the last century set stories there, tales of explorers pushing through humid alien forests, of dinosaurs in the mist, of a second Eden next door waiting for us to arrive. The twin planet was not just similar in size. In our dreams, it was alive. I want you to hold on to that feeling for a moment, the warmth of that old hope, because the whole story of Venus is the story of that hope meeting reality. And reality, on Venus, is unlike anything our gentle imaginations prepared us for. The first cracks in the dream did not come from a telescope looking at the clouds. They came from a new way of listening. In the middle of the last century, astronomers began to study Venus not with visible light, but with radio waves. Every warm object gives off radiation, an invisible glow tied directly to its temperature. The warmer something is, the more strongly it shines in these unseen wavelengths. So scientists pointed radio telescopes at Venus, expecting to measure the gentle warmth of a mild and pleasant world. What they found instead made them check their instruments again and again. The radio signal coming from Venus was screaming. It was the signal of something not merely warm but ferociously, impossibly hot. The numbers suggested temperatures far beyond boiling. At first, many refused to believe it. Surely there was some mistake, some other explanation, some quirk in the planet's atmosphere creating a false glow. The dream of the warm swamp world does not die easily, but the signal held. The heat was real, and it was only the beginning of the strangeness. Then, we did something our ancestors could only dream of. We stopped looking from a distance, and we started to go. In the early days of the space age, both of the great spacefaring nations of the time turned their eyes toward Venus, because it was so close and so tempting. The very first spacecraft ever sent to another planet was sent to Venus. Think about that for a moment. Before we landed anything on Mars, before the great outer voyages, our first real reach across the Gulf to another world was aimed at our bright sister. We were going to visit the twin. The early missions were brutal lessons. Many failed before they ever arrived, lost in the dark, silenced by the difficulty of it all. But some made it, sweeping past the planet and turning their instruments toward those clouds. And one by one they confirmed the impossible news. The atmosphere was almost entirely carbon dioxide. It was unbelievably thick, and it was hot, far hotter than any place a human could survive, hot enough that the idea of oceans became laughable. There were no warm seas under those clouds. There could not be. Any ocean that ever existed there would have long ago boiled away into the sky. Each new measurement peeled away another layer of the old dream. The jungles vanished first, then the oceans, then the very idea of standing comfortably anywhere on its surface. The twin planet, the sister world, the second Eden, was revealing itself to be something closer to the old idea of an underworld, a place of unending heat and crushing weight and poisoned air. And yet, and this is the part that keeps pulling scientists back across the decades, it remained our twin in all the ways that should have mattered. Same size, same rock, same beginning, same sun, more or less, shining down. Let me linger a little longer on how slowly this understanding arrived, because the story of how we came to know Venus is itself a kind of gentle drama, and it deserves a quiet telling. For thousands of years, Venus was simply a light, a wanderer among the fixed stars. The ancient sky watchers of many lands tracked it with extraordinary care, recording its risings and its settings, weaving it into their calendars and their myths. They named it, again and again, after their goddesses of love and beauty, for it was the most beautiful light in the heavens. The name we still use today comes from the Roman goddess of love, and there is a soft irony in that the most lovely point in our sky should belong to the most savage surface we have ever found. We named the furnace after beauty because all we could see was the glow. The first crack in the pure mystery came when the telescope was invented 4 centuries ago. When the early astronomers turned their new instruments toward that bright light, they discovered something that quietly reshaped our understanding of the entire solar system. Venus had phases. Like the moon, it showed a slim crescent, then a half, then a fuller shape, then back to a crescent, growing and shrinking in size as it did so. This was a profound clue. It meant Venus was circling the sun, not the Earth, lit from different angles as it swung around our star. That gentle pattern of light and shadow on a single bright dot helped overturn the old idea that everything revolved around us. Venus, our beautiful twin, was one of the first witnesses to the true shape of things. But even with telescopes, the surface stayed hidden. Look at Venus through even a powerful instrument and you see almost nothing. No continents, no markings, no features. Just a smooth, blank, dazzling disk, sometimes a delicate crescent, always featureless. Generation after generation of astronomers strained at that blank face and saw only the tops of the clouds. Some thought they glimpsed faint shadows and tried to use them to measure how fast the planet turned, and they came away with wildly different answers, because there was nothing solid to track. Venus simply would not show herself. That blankness is why the dreams lasted so long. There was nothing to contradict them. A featureless white world is a perfect screen onto which to project whatever you hope to find. And for centuries, what we hoped to find was a living, watery sister. It took entirely new kinds of eyes to finally pierce the veil. Not eyes for visible light at all, but for radio waves, which can pass through clouds as though they were not there. By bouncing radar off Venus and listening for the echo, astronomers did 2 remarkable things at once. They measured, for the first time, how the planet truly spins, uncovering the slow backward rotation we will explore later. And eventually, by mapping those radar echoes in fine detail, They began to draw the first true maps of the hidden surface, revealing vast volcanic plains, broad highland regions, and the scars of an ancient and violent geology. The veil that had hidden Venus since the beginning of human looking was, at last, lifted, not by light, but by radio, not by the eye, but by the echo. And what lay beneath was no jungle and no ocean, but a dry, volcanic, broken world baking under its impossible sky. This is the puzzle that sits at the center of everything. Two planets are born side by side, two nearly identical balls of rock and metal, the same distance, give or take, from the same star. One of them becomes the blue and green and white world you live on, draped in gentle oceans, breathing a soft mix of air, cool enough for rain and warm enough for rivers, a world so kind that it grew you. And the other becomes a furnace wrapped in acid, the most hostile surface in the entire solar system, a place that would destroy any visiting machine in a matter of hours. Same starting point, opposite endings. How? That single quiet word is what we are going to spend our time together unfolding. How does a twin become a stranger this complete? How does a world that should have been our second home become the closest thing to a vision of ruin that nature has ever built next door? And let me plant one more seed before we go deeper, because it is the seed that gives this whole journey its weight. The differences between Earth and Venus are not only a curiosity, they are a warning written in rock and air. Whatever happened to Venus did not have to happen. It was not destined from birth. Something tipped it over an edge, and once it went over, there was no coming back. The same physics that runs on Venus runs here. The same sun that cooked our sister also shines on us. And so when we study what went wrong over there, we are not only satisfying our curiosity about a strange and distant place, we are, in a very real sense, reading a possible chapter from our own deep future. We are looking at one of the ways a living world can die. But I am getting ahead of us, and tonight is not a night for fear. Tonight is a night for wonder, for the slow pleasure of understanding something vast and strange, one calm step at a time. So let us hold the question lightly and simply begin to look. Picture us drifting toward it now, not falling, just floating, the way you float at the edge of sleep, weightless and unhurried. From far away, Venus is gorgeous. A smooth, creamy globe with no sharp features, no blue oceans, no swirling storms like the ones you can see on Earth from space. Just soft bands of pale gold, featureless and serene, turning so slowly you can barely tell it moves at all. It looks from out here like the calmest place imaginable, like a pearl resting on black velvet. There is nothing in that gentle view to suggest the violence underneath. That gap between how peaceful it looks and how savage it truly is may be the most honest thing about Venus. It is a planet that wears a soft and beautiful mask. It fooled us for centuries with that mask, let us dream our jungle dreams and our ocean dreams right up until our instruments and our brave little machines finally slipped beneath the veil. And what they found there is a world so extreme that even now, knowing the numbers, our minds struggle to truly hold it. So over the next stretch of our journey, I am going to take you under that veil, slowly and carefully, one strangeness at a time. We will stand in our imaginations on a surface hotter than a kitchen oven turned as high as it will go. We will feel an air so heavy It is more like an ocean than a sky. We will watch a sun rise in the wrong direction across a day so long it outlasts the planet's entire year. And we will listen very carefully to a faint and disputed whisper high in the clouds that made some scientists wonder, just for a moment, whether something might be alive up there after all. But first, the heat. Because the heat is where the dream of the twin truly died, and where the real story of Venus begins. There is a number waiting for us, a single temperature, and it is so high and so wrong for a planet in this position that for a while it simply did not make sense. A planet farther from the Sun than Mercury has no business being hotter than Mercury, and yet it is, by a wide and impossible margin. Let me show you why. Let me show you how a world tips over the edge, how a small difference becomes an inferno, and how the same invisible blanket that keeps your nights from freezing can, in the wrong amount, turn an entire planet into the hottest surface this side of the Sunday settle in. Breathe slowly. We are going down into the heat now, and I promise to keep you safe the whole way through. Here is the number. The surface of Venus sits at roughly 467 degrees Celsius. Let me say that again, slowly, so it has room to land. 467 degrees Celsius. That is hot enough to melt lead. It is hot enough to melt tin and zinc. It is far hotter than the inside of your oven could ever go. Hotter than the temperature used to fire pottery. Hot enough that a block of metal left on the surface would slowly soften and sag. And this temperature is not found only in one scorched desert at the planet's equator. It is everywhere. The poles are this hot. The deep night side is this hot. The tops of the mountains are this hot. The whole surface of Venus, every square meter of it, rests at very nearly the same searing temperature all the time. Now sit with how strange that already is, before we even ask why. On Earth, the temperature changes everywhere you go. The equator bakes while the poles freeze. The desert at noon could cook you, while the same desert at night turns cold enough to need a fire. Climb a tall mountain, and the air grows chill even at the equator. Move into the shadow, and you cool down. Step into the sun, and you warm up. Our world is a patchwork of temperatures, a quilt of warm and cool stitched together by day and night and latitude and altitude. Venus has almost none of that. It is one single, uniform, unrelenting temperature from pole to pole and from noon to midnight. That uniformity is itself a clue, and we will return to it. But first, the deeper riddle. Venus is the second planet from the Sunday, Mercury is the first. Mercury huddles far closer to that great fire, so close that it races around the sun in just 88 days, so close that the sun looms huge and terrible in its black sky. Common sense says Mercury should be the hottest planet. It is nearest the furnace. It should win. And during its long blazing day, Mercury does get ferociously hot, its sunlit side climbing to around 430 degrees Celsius. That is brutal, but notice, it is still cooler than Venus. Venus, sitting nearly twice as far from the sun, receiving only about a quarter of the raw sunlight per square meter that Mercury receives, is nonetheless the hotter world. The planet that gets less sunlight is hotter than the planet that gets more. The farther one wins. This should bother you in the best possible way. It bothered scientists deeply when they first confirmed it. It breaks the simple rule we all carry, the rule that says closer to the fire means warmer. So something on Venus is not playing by the simple rule. Something is taking the smaller amount of sunlight that Venus does receive and refusing, absolutely refusing, to let the resulting heat escape back into space. To understand Venus, we have to understand that refusal. And to understand the refusal, we have to do something that feels almost backward. We have to talk about how Venus actually keeps most sunlight out in the first place. Remember those beautiful, bright, reflective clouds, the ones that make Venus shine like a jewel in our evening sky. They are not just pretty, they are a mirror. Venus is the most reflective planet in the solar system. It throws back into space something like 70% of all the sunlight that reaches it. Compare that to Earth, which reflects only about a third of the light it receives and absorbs the rest. So here is the first twist of the knife. Venus is not hot because it soaks up sunlight. It actually rejects most of the sunlight that arrives. The vast majority of the sun's light never even reaches the ground. It bounces off the high cloud tops and flees back into the dark. Only a thin trickle of sunlight, filtered and dimmed by kilometers of dense cloud and air, ever makes it all the way down to the surface. So picture standing on that surface. If a body could survive it, it would not be blindingly bright. It would be a dim, heavy, orange-tinted gloom, like a thick, overcast day right before a storm, or like the last light of a deep red sunset that never ends. The sun itself would not even be visible as a disk. The clouds are far too thick for that. You would just have a sourceless, rusty glow soaking through from above. And yet, in that dim and shadowy light, the rocks around you are hot enough to glow faintly on their own and to melt soft metals. A dim world, a scorching world, both at once. How? Here is the heart of it, and I am going to build it up gently, layer by layer, because this is the single most important idea on Venus, and it is one of the most important ideas about your own planet as well. It has a name, the greenhouse effect, and before it became a phrase you hear in the news, before it carried any worry at all, it was simply a beautiful piece of physics that keeps you alive every single night. Let me show you the kind version first, the version that happens at home. Sunlight arrives at a planet as visible light, the kind your eyes can see. That light passes down through the air and strikes the ground, and the ground absorbs it and warms up. Now, a warm surface does not just sit there. It glows, not in visible light, but in infrared light, a longer, slower, invisible kind of radiation. This is the planet trying to send its heat back out into space, trying to balance the books, letting go of as much energy as it takes in. If nothing got in the way, the heat would simply leave, and the surface would settle at a cool and predictable temperature. But something does get in the way. Certain gases in the air, and carbon dioxide is the most famous of them, have a peculiar talent. They let the incoming visible sunlight pass right through without much trouble. But they absorb the outgoing infrared glow. They catch that rising heat and hold it for a moment, then radiate it back out in all directions, including back down toward the ground. So the heat that was trying to escape gets caught, sent down, caught again, sent down again. The surface stays warmer than it otherwise would. That is the greenhouse effect, and on Earth it is a blessing. Without it, our planet would be a frozen ball, with an average temperature well below freezing, far too cold for liquid water or for life. Our gentle dose of greenhouse gases is the blanket that keeps Earth's nights from killing everything. You should feel grateful for it. It is part of why you are warm right now. So it is not the existence of the greenhouse effect that destroyed Venus. It is the amount. On Earth, carbon dioxide is a trace gas, a tiny fraction of the air, measured in parts per 10,000. On Venus, carbon dioxide is the air. The atmosphere of Venus is over 96% carbon dioxide. Almost the entire ocean of gas wrapped around that planet is the very gas that traps heat most stubbornly, and there is so much of it. The atmosphere of Venus is staggeringly thick and heavy, far more massive than our own. Imagine the gentle blanket that keeps Earth comfortable, and now imagine it thickened into a suffocating wall, dozens of times heavier, made almost purely of the one gas best at refusing to let heat go. That is the sky of Venus. A blanket so thick that the heat trying to rise from the surface is caught and caught and caught again, sent back down 1,000 times over, until the surface has no choice but to climb to a temperature high enough to finally force a little energy out through that impossible wall. And that balancing temperature, the point where the trickle of escaping heat finally matches the trickle of arriving sunlight, is 467 degrees. That is why the dim planet is the hot planet. That is why the farther world beats the nearer one. Mercury has almost no atmosphere at all, so its daytime heat radiates freely back into space the moment night falls, and its night side plunges to hundreds of degrees below freezing. Mercury cannot hold its heat. Venus cannot lose its heat. One has no blanket. The other has a blanket so thick it has become a tomb. But how did it get this way? A planet does not begin its life with an atmosphere 90 times heavier than Earth's, almost pure carbon dioxide, hot enough to melt lead. Venus had to become this. And the story of how it became this is the story of the runaway greenhouse, one of the most important and sobering processes in all of planetary science. Let me walk you through it slowly, because it is a chain of events where each link pulls the next. And once it truly starts, it cannot be stopped. Go back billions of years. Picture a young Venus that might have looked far more like Earth. Many scientists now think early Venus may have had water, perhaps shallow oceans, perhaps clouds that rained. A cooler, gentler, more familiar world, sitting just a little closer to a slightly fainter young Sunday. For a while, it may have been one of the most habitable places in the solar system. Hold that image, because it is both beautiful and heartbreaking. The furnace may once have been a water world. Now begin the slide. Venus is a little closer to the sun, so it receives a little more sunlight than Earth does. A little more warmth means a little more water evaporating from those early oceans into the air. And here is the cruel turn. Water vapor is itself a powerful greenhouse gas. So more water vapor in the air traps more heat. More trapped heat warms the surface further. A warmer surface evaporates still more water, which traps still more heat. Do you feel the loop closing? Each step feeds the next and makes it stronger. Warmer air, more vapor, more trapping, warmer still. This is the runaway. It is a feedback that does not settle down but builds on itself, faster and faster, like a small push at the top of a long slope that becomes an unstoppable fall. On Earth, this loop is held in check. Our oceans are stable, our temperatures are mild enough that the cycle never gets going, never reaches escape velocity. But on early Venus, with that extra nudge of sunlight, the loop caught fire. The oceans evaporated entirely, every drop of them rising into the sky as scalding vapor, wrapping the planet in a dense, hot, water-rich atmosphere that trapped more and more heat. And up high, the water vapor met the harsh ultraviolet light of the sun, which broke the water molecules apart. The light hydrogen escaped into space, lost forever, carrying away Venus's water for good. What remained was the carbon dioxide, which on Earth gets locked away into rocks and oceans over long ages, but on Venus had no cool ocean left to dissolve into and nowhere to hide, so it stayed in the air. It piled up. It built that 90 times heavier blanket, and the temperature climbed and climbed and climbed until it reached the searing equilibrium it holds today. That is the runaway greenhouse, a world that may have started with oceans, tipped just slightly too far toward the sun, falling step by step into an inferno from which there is no return. The water gone, the carbon dioxide trapped, the heat permanent. I want to slow down here and sit with one detail in that story, because it is the detail that turns a piece of physics into something almost tragic: the loss of the water. On a living world, water is not just for drinking and for oceans. Water is part of how a planet regulates itself, part of how carbon gets pulled out of the air and locked away into stone over long ages. On Earth, rain washes carbon dioxide out of the sky. Rivers carry it to the sea, and there it is slowly bound into rock, buried, taken out of circulation. This is one of the quiet thermostats that keeps our world steady. A slow cycle that has kept Earth livable for billions of years. It needs liquid water to work, and when Venus lost its water, when every drop rose into the sky and the hydrogen fled to space, that thermostat broke. There was no more rain to scrub the carbon dioxide from the air. There was no more ocean to absorb it. So the carbon dioxide that volcanoes kept breathing out across the ages had nowhere to go. It simply accumulated, century upon century, building that 90 times heavier blanket with nothing left to take it back down. The loss of the water did not only dry the planet, it removed the very mechanism that might have saved it. Once the water was gone, Venus was committed, and consider how little it may have taken to start the fall. This is the part that should make you sit up gently in the dark. Venus is not dramatically closer to the Sun than Earth. It is only about 30% nearer. In the grand scheme of the solar system, that is a small step. The two worlds receive light from the same star, formed from the same cloud, are built of the same rock. The difference in their starting positions was modest, and yet that modest difference, that small extra dose of warmth, may have been enough to push Venus across a line that Earth never crossed. One planet stayed on the cool side of the threshold and grew gardens. The other slipped just over it and became a furnace. The margin between the two fates may have been far thinner than any of us would like to believe. That is not a thought to frighten you tonight. It is a thought to make you marvel at how finely balanced our own good fortune truly is. There is one more piece of the heat worth understanding before we move on, and it concerns the night. I told you that the night side of Venus stays just as hot as the day side, and I want you to feel how genuinely strange that is. On Earth, the ground gives up its heat quickly once the sun sets. Step into a desert after dark and you can feel the warmth draining out of the sand, escaping upward into a clear sky, the cold pressing in within hours. That is a planet letting go of its heat. Venus cannot let go. The blanket is too thick. The atmosphere holds so much energy and traps the outgoing glow so completely that even through a night lasting nearly 2 of our months, the surface temperature barely flickers. There is no cooling in the dark. There is no relief at dawn or dusk. The heat is not a thing that comes and goes with the Sunday. It is a permanent condition of the whole planet, baked in so deep that the daily rhythm of light, which governs almost everything about temperature on Earth, means almost nothing on Venus. The furnace does not rest. It cannot. And now, finally, look back at that strange uniformity I mentioned, the way every part of Venus rests at almost the same temperature. The blanket explains it. The atmosphere is so thick and so heavy that it behaves less like air and more like a deep, sluggish ocean of gas. It stores an immense amount of heat, and it moves that heat around so thoroughly that no part of the planet is allowed to cool. The night side, which on Venus can last for nearly 2 of our months at a time, never gets a chance to chill. There is simply too much hot gas pressing down on it, holding the warmth in place. The poles, the equator, the mountaintops, the deep plains, the long day, the long night, all of it the same merciless heat. The blanket does not allow for cold corners. So the heat is not a surface fact. It is a whole planet condition enforced by an ocean of trapping gas that never lets go. And here is the quiet thought I want to leave you with before we go further down. The temperature, as staggering as it is, may not even be the strangest thing about Venus, because we have only talked about how hot that ocean of air is. We have not yet talked about how heavy it is, how it would feel to actually stand beneath it, how its weight alone could crush a submarine, and what it is truly made of. We have been describing the blanket. Now it is time to feel its weight. Stay with me and breathe easy while we sink down into the crushing sea of air that is the sky of Venus. Let us go down now, gently into the air. And I want you to set aside the word air entirely, because it is too soft and too thin for what waits below those clouds. What surrounds the surface of Venus is not air in any way your body would recognize. It is closer to an ocean, a dense, hot, invisible sea of gas pressing down on every stone with a weight that is difficult to truly imagine. Here is how heavy it is. The atmospheric pressure at the surface of Venus is about 90 times the pressure at the surface of Earth. 90 times. To feel what that means, you cannot look to the sky, you have to look to the deep sea. On Earth, to find a pressure 90 times what you feel right now, you would have to dive down into the ocean to a depth of nearly 1 kilometer below the waves. Picture that. Picture sinking down through the dim blue, past the depth where sunlight fails, down into the black water where the pressure would crush an unprotected human body in an instant, where only specially built vessels can go. That is the pressure waiting at the surface of Venus, except it is not water pressing on you, it is gas. The very sky itself, grown so thick and heavy that standing on the ground of Venus is like standing on the floor of a deep, warm, poisoned sea. Stay with that feeling for a moment, because it changes everything about how you imagine the place. We tend to picture the surface of another planet the way we picture a desert here, with open air and a clear sky and a horizon you could walk toward. But the surface of Venus is nothing like that. It is the bottom of an ocean of air. The atmosphere is so dense that it would press on you from every side at once, a constant, total, crushing embrace. It is so dense that it bends light, curving your view upward so that the ground in the distance might appear to rise around you, as though you were standing in the bottom of a shallow bowl. It is so dense that sound would travel through it strangely, lower and deeper, your own voice transformed into something slow and heavy. And the weight of this ocean of air is not a gentle thing. We learned exactly how unforgiving it is the hard way, through a long and quietly heroic series of machines that we sent down into it. Machines that gave their short lives so that we could glimpse, just for a few minutes at a time, the surface no human eye had ever seen. This is one of the most remarkable and underappreciated chapters in the history of exploration, and I want to give it the slow attention it deserves. In the heart of the last century, the Soviet space program made Venus its great obsession. They built a series of landers called Venera, which simply means Venus in their language, and they tried again and again to set a working machine down on that impossible surface and have it survive long enough to send something back. The early attempts were heartbreaking. Probe after probe was lost. Some failed on the way. Some made it into the atmosphere only to be crushed before they reached the ground, flattened by that ocean of air like a tin can in a vice, their signals going silent while they were still high above the surface. The engineers kept building them stronger, thicker hulls, reinforced shells, designed to survive pressures that would destroy a submarine. They were not building spacecraft so much as building deep-sea vessels meant to fall through the sky. And slowly, against enormous odds, they began to succeed. One probe became the first machine ever to transmit from within the atmosphere of another planet. Another became the first to survive all the way to the surface and send a signal from the ground of another world. A faint voice from the floor of the Venusian Sea, lasting only a few minutes before the heat and pressure overwhelmed it. And then, finally, came the moment that still gives me chills to describe. A later Venera probe reached the surface, and before it died, it opened its eye. It took a photograph. For the first time in all of human history, we saw the ground of Venus. Imagine the people in that control room, waiting, as the data trickled back across tens of millions of kilometers and slowly assembled itself into an image. And there it was. Not a swamp, not an ocean, not a jungle. A flat, broken, desolate plain of slabby orange-grey rock stretching to a hazy horizon under a sourceless amber light. Sharp-edged stones scattered across hard-packed ground. A landscape that looked, in its bleak way, almost familiar, like a stretch of volcanic desert, except for that strange, glowing sky, and the knowledge that the gentle-looking light was hot enough to kill in moments, and the calm-looking air was heavy enough to crush. Those probes survived for less than an hour. Most lasted only a handful of minutes. The heat seeped through their armor and cooked their instruments. The pressure strained every seam. They were the toughest machines we could build, and Venus killed every one of them almost as soon as it arrived. The the way you might brush away a snowflake. That is the surface we are standing on in our imaginations tonight. A place that destroys our finest creations in the time it takes to brew a pot of tea. And yet for those few precious minutes, they looked and they sent home the view. And because of their sacrifice, we know what the floor of that hidden ocean of air truly looks like. Now, let us rise back up, away from the deadly surface, and look at the clouds themselves, because they are their own kind of wonder and their own kind of horror. From a distance, they are soft and pale and lovely. Up close, they are made of something that would dissolve you. The clouds of Venus are not water clouds. They are clouds of sulfuric acid, droplets of concentrated acid, suspended in a sky of carbon dioxide, wrapped in thick, unbroken decks tens of kilometers above the surface. And it rains there. High in the atmosphere, droplets of sulfuric acid form and fall, a slow acid drizzle sifting down through the upper sky. But here is one of the strangest and most poignant details on the whole planet. The rain never reaches the ground. As those acid droplets fall, they descend into the deeper, hotter layers of the atmosphere, and somewhere along the way, long before they touch the surface, the heat becomes so intense that the rain evaporates. It turns back into vapor and rises again. So Venus has rain that falls forever and never lands. A weather of acid hanging in the sky, cycling down and boiling back up, never once wetting the stone below. There is a kind of terrible poetry in that, a planet weeping a rain that the heat will not allow to fall. Let me ask you to feel that acid for a moment, not as a chemistry term, but as a presence. Sulfuric acid is one of the harshest substances we know. It scars metal, eats through cloth, blisters skin, and on Venus, it is not a spill in a laboratory, it is the weather. It is the substance the clouds themselves are made of, hanging in vast pale decks around the entire planet, the very thing that gives Venus its soft and beautiful glow from afar. The same brightness that made our ancestors name the planet after the goddess of beauty is the light of an unbroken ocean of acid cloud. Beauty and corrosion, the same fact seen from two distances. From here, a jewel. From within, a haze that would dissolve almost anything we could send into it. And those clouds are not thin. They are tens of kilometers deep, layer upon layer, so that a probe falling through them would spend a long time inside that pale acid murk before it ever broke through into the clearer, darker, hotter air below. The sky of Venus is layered, like a great structure built of haze. Down near the surface, beneath the main cloud decks, the air is strangely clear, that dim orange murk where the Venera probes took their pictures. Above that, the thick clouds begin, deck upon deck of acid haze, the dense yellow-white shell that hides the planet from our eyes. And it is in and above those high clouds that we find the next great strangeness, one that for years no one could explain. The clouds are moving fast, furiously, impossibly fast. The upper atmosphere of Venus races around the entire planet in just about 4 Earth days, winds tearing along at hundreds of kilometers per hour, faster than the strongest hurricane you have ever heard of. This howling river of clouds sweeps around and around the globe without stopping. Scientists call it super rotation, and the name captures the puzzle perfectly. The atmosphere is rotating far, far faster than the planet underneath it. The whole sky is spinning like a top, while the ground beneath barely turns at all. And that contrast is where Venus becomes almost dreamlike in its strangeness. Because the planet itself, the solid body of Venus, turns with agonizing slowness. While the upper clouds whip around the globe every 4 days, the surface takes hundreds of days to complete a single turn. Imagine standing on that ground in the dim orange light, the air pressing on you like deep water, the acid sky glowing far overhead, and knowing that the clouds racing past above you are circling the entire planet in the time it takes for the ground under your feet to barely shift, a frantic, screaming sky over a ground that hardly moves. It is one of the most surreal arrangements anywhere in the solar system, and we still do not fully understand how that super-rotation is powered and sustained, how the thin upper winds manage to keep racing without slowing down. There is more to say about those landers, because their story is one of the most quietly moving in all of exploration, and it tells us something about the surface that no number ever could. Think about the problem the engineers faced. They had to build a machine that could survive a fall through an atmosphere so thick it behaved like water, then endure a heat that would melt the soft metals inside ordinary electronics, then keep working long enough to gather data and beam it home, all while being slowly cooked and crushed from every direction. Their solution was to treat the probes almost like deep-diving submarines. Thick, rounded, pressure-resistant shells. Some were chilled down to extreme cold before release, so they would have a little thermal cushion, a head start against the heat, buying a few extra precious minutes before the warmth crept in and ended them. They were, in a sense, sent down already bracing for death, designed only to live long enough to look, and when they reached the ground, they faced a final indignity that tells you everything about Venus. On at least one descent, the lens cap that was meant to pop off so the camera could see is thought to have not fully cooperated, or a probe came to rest at an awkward angle, so that some of the precious imaging time was spent staring at the probe's own structure or at the ground beneath it rather than the open landscape. Tiny human imperfections, playing out tens of millions of kilometers away, in a place no person could ever go to fix them. And yet, even through all of that, the images came. Grainy, strange, otherworldly, and utterly real. The first photographs from the surface of another planet were not from Mars or the Moon. They were from the floor of the Venusian sea of air, taken by brave, doomed machines in the few minutes before the most hostile place we know swallowed them whole. What strikes me most about those pictures is the ordinariness of the rock against the impossibility of the conditions. The stones look almost like stones you might find in a volcanic field on Earth. Flat, slabby, broken plates of basalt, the cooled blood of ancient volcanoes. Venus is a deeply volcanic world. Its surface is dominated by vast plains of hardened lava, by broad shield volcanoes, by strange circular features unlike anything on Earth, by highlands that rise like continents from the volcanic seas of stone. And there are signs, debated but tantalizing, that some of those volcanoes may not be entirely dead, that Venus may still be geologically restless even now, still resurfacing itself, still breathing out the gases that feed its terrible sky. A world that looks, in a single grainy photograph, almost familiar, almost like a quiet stretch of desert at dusk, until you remember that the dim light is lethal and the still air is heavy enough to kill. Let me try to gather all of this into a single picture so you can feel the place as a whole rather than as a list of facts. Stand with me on the surface of Venus, just for a moment, protected by imagination alone. Beneath your feet, hard volcanic plains, sharp orange-grey stone, stretching flat to a hazy bent horizon. Around you, an ocean of air 90 times heavier than home, pressing on every part of you, dense enough to crush a submarine, hot enough at 467 degrees to melt the lead in a pencil and soften metal. The light is dim and rusty, a permanent stormy gloom. The sun invisible behind kilometers of cloud. Far above, decks of pale acid haze glow faintly, and beyond them the great winds race around the planet in their endless 4-day sprint. Acid rain falls from those clouds and boils away before it can land, weeping into a sky that will never let it touch the ground. And it is silent, or nearly so, except for whatever deep, slow sounds that heavy air would carry. No birds, no water, no movement, save the distant racing of the clouds you cannot even see through the haze. This is the most hostile surface in the solar system, and I do not say that lightly. There are colder places, there are places with more radiation, but for sheer, total, simultaneous hostility, for heat and pressure and corrosion and gloom all stacked together into one unbroken assault, nothing matches the floor of Venus. It is the closest thing nature has built to the old human idea of an underworld, a realm of fire and weight and poison, sitting right next door on the planet we once dreamed held jungles. And yet, and here is the gentle turn I want to leave you on, the small flicker that will matter later in our journey. It is not hostile everywhere. If you do not stand on the surface, if instead you rise up through the crushing dark, up past the worst of the heat, up to a height of around 50 kilometers above the ground, something remarkable happens. The pressure eases until it is close to the pressure you feel right now at sea level on Earth. The temperature cools from that lead melting fury down into a range that is almost mild, almost comfortable, the kind of warmth you might feel on a summer afternoon. High in the clouds of Venus, far above the deadly ground, there is a thin layer where the conditions are, by the standards of this savage world, astonishingly gentle. It is still a strange place up there, wrapped in acid haze and racing winds. But the raw, crushing impossibility of the surface gives way, at that height, to something a scientist might cautiously call habitable, at least in terms of temperature and pressure. And that quiet fact, that one mild layer floating high above the inferno, is the thread that leads us toward the most controversial and most human question in the whole story of Venus. The question of whether anything could possibly live there. The question that, just a few years ago, exploded into headlines around the world when a faint chemical whisper drifted down from exactly that layer of cloud. But before we follow that whisper, there is still one more strangeness to feel. The strangeness of time itself on Venus. The backward Sunday, the day that outlasts the year. Let us slow down even further and step into the strange clock of this world. Time is something we almost never think about as a property of a planet. It feels universal, like it belongs to the cosmos rather than to any particular world. But time, as you live it, the rhythm of day and night, the length of a year, the direction the sun travels across your sky, All of that is made by your planet. It is built from how fast Earth spins and which way it spins and how it moves around the Sunday. And on Venus, every one of those things is broken, or rather, every one of them is set to a different and stranger setting than anything we know. To stand on Venus would be to step into a clock that runs wrong in almost every way at once. Let us start with the direction. On Earth, and on nearly every other planet in the solar system, the world turns in the same direction it orbits the Sun, a direction we can call forward. This is why everywhere on Earth, the Sun rises in the east and sets in the west. It has done so for every dawn of every life that has ever existed here. East to west, it is so deep in us that the words themselves carry the meaning. The east is where light begins. On Venus, it is reversed. Venus spins backward. It rotates in the opposite direction to almost everything else in the solar system, a motion astronomers call retrograde. And the consequence of that backward spin is quietly astonishing. On Venus, if you could see the sun through those thick clouds, it would rise in the west and set in the east. The exact opposite of every sunrise in human history. The light would begin in the wrong place. It would climb the sky the wrong way and sink down on the wrong horizon. Every instinct you carry about morning and evening, about which way is dawn, would be turned around. Now sit with how disorienting that is. Not as a fact, but as an experience. You have a sense, somewhere deep below thought, of how the day moves, of the sun arcing one way across the heavens. On Venus, that arc is flipped. And it is not the only thing flipped, because the timing is unlike anything we have a word for. To understand it, we have to separate two ideas that on Earth are close cousins, but on Venus are wildly estranged. The day and the year. A year is how long a planet takes to travel once around the Sunday. Venus is closer to the Sun than we are, and the closer you orbit, the faster you go, so Venus completes its year quickly. A single trip around the Sun takes Venus about 225 Earth days. So a Venus year is shorter than an Earth year, a little under 8 of our months. That is reasonable enough. Nothing shocking there. A day, though, is different. A day is how long a planet takes to spin once on its own axis, to turn so that the Sun returns to the same place in the sky. And Venus spins with almost unbelievable slowness. It turns so slowly that a single rotation takes about 243 Earth days. Let me set those two numbers side by side, because their relationship is one of the most beautiful and bewildering facts in the solar system. The year, the trip around the Sun, takes about 225 Earth days. The day, the single spin, takes about 243 Earth days. Look at that closely. The day is longer than the year. On Venus, the time it takes the planet to spin once is greater than the time it takes to circle the entire Sunday. A day on Venus outlasts a year on Venus. Read that again and let it bend your mind a little, because it deserves to. We are so used to days being small and years being large. A year holds hundreds of days here. The day is the quick beat, and the year is the long song. On Venus, that whole relationship inverts. The planet races around the Sun while barely managing to turn itself over once. You could be born and the planet would complete a full year, a full journey around the Sun, before it had even finished a single rotation. The very units of time we take for granted are tangled and reversed. And because the spin is so slow and runs against the orbit, the actual experience of a solar day, the time from one sunrise to the next as you would feel it standing on the surface, works out differently still. Counting from one western sunrise to the next, a single day and night cycle on Venus lasts around 117 Earth days. So if you stood on that dim orange plain and waited for the sun to rise in the west, climb slowly across the sky and set in the east, and then rise again, you would wait nearly 4 Earth months for that one cycle to complete. The daylight alone would stretch on for almost 2 of our months. Then the night would fall, and it too would last for nearly 2 of our months, a darkness longer than an entire season at home. Try to imagine living through one Venusian day, not as a number, but as a slow, lived experience. The sun creeps up over the wrong horizon and begins a crawl across the sky, so gradual that for weeks it would seem almost not to move at all. There is no morning rush, no afternoon, no evening in any sense your body understands. There is only the long, long brightening, day after Earth, day after Earth, day of the same dim amber glow slowly shifting. And then, after the better part of 2 months, the long, long dimming as the sun takes weeks to sink toward the eastern edge of the world. And then night, a night that does not last hours but lasts and lasts, week after week of unbroken dark, and yet a dark that never grows cold, because remember the blanket, the ocean of air that holds the heat so completely that even in 2 months of night, the surface never cools from its lead melting fury. Endless slow day, endless slow night, the same searing heat through both. Time itself stretched into something almost unrecognizable. Let me offer you one gentle way to picture just how slow this rotation truly is, because the numbers can wash over you if you are drifting towards sleep, and I want this one to stay. Imagine you could stand on the surface of Venus in that dim orange light, and you decided to walk, not quickly, just an easy, strolling pace, the kind of walk you might take on a quiet evening. If you walked steadily in the right direction, you could very nearly keep pace with the Sunday. You could, in principle, stroll fast enough that the sun would seem to hang almost still in the sky, neither rising nor setting, simply waiting there in the haze above you as you walked on and on. The planet turns so slowly beneath your feet that a human walking pace is in the same league as its spin. There is no other world in the solar system where you could outpace the day on foot. On Venus, the turning of the planet is so gentle, so unhurried, that the ground moves slower than a wanderer. Hold that image as you rest. A world so slow that you could walk beside its dawn. Why? Why does Venus spin backward? And why does it spin so impossibly slowly? This is one of the genuine open questions of planetary science, and I love it for its honesty, because the truthful answer is that we are not entirely sure. But there are ideas, good ideas, and they are worth walking through slowly, because each one tells us something about how violent and chaotic the early solar system truly was. The first idea is the most dramatic. Perhaps, long ago, in the chaos of the young solar system, when worlds were still forming and colliding, Venus was struck. A giant impact, a collision with another large body, could in principle have knocked the planet over or reversed its spin. the way a cue ball can send another ball spinning backward. We know such collisions happened. Our own moon is thought to have been born from a colossal impact between the young Earth and another world. So it is not unreasonable to imagine that Venus took a blow so enormous it flipped the planet's rotation, or tipped Venus nearly upside down so that what was once a forward spin now appears, from our point of view, to be backward. This is a real possibility, and for a long time it was a leading guess. But there is a second idea, subtler and in some ways even stranger, and it brings us right back to that thick, heavy, restless atmosphere. Remember how massive the air of Venus is, how it behaves almost like an ocean, how the upper layers race around the planet in their 4-day super rotation. An atmosphere that heavy and that active is not a passive thing. It pushes, it drags. It exchanges momentum with the solid planet beneath it, and it also feels the gravitational pull of the distant sun, which raises slow tides in that dense ocean of gas. Over enormous spans of time, the gentle, ceaseless tug of solar tides on that immense atmosphere, combined with the friction between the racing air and the slowly turning ground, could have acted like a brake and a lever together, gradually slowing Venus down and nudging it toward the strange, slow, backward spin we see today. In this picture, Venus did not need a single catastrophic blow. It was talked into its strange rotation slowly, over billions of years, by the patient hands of its own atmosphere and the Sunday. It may even be that the truth is some marriage of these ideas, an early tilt or impact setting the stage and the atmosphere finishing the job across the ages. We do not yet know for certain, and I find that lack of certainty wonderful rather than frustrating. It means Venus is still keeping secrets. It means there are answers waiting in that dim orange world for the missions we have not yet flown. Let me draw out one more strange consequence of this slow backward turn, because it touches something we almost never have to think about. The position of the sun and the position of the stars come apart on Venus in a way they never do for us. Here on Earth, our day and our spin are closely matched, so the sun and the stars wheel across the sky together at roughly the same pace. On Venus, the planet's slow backward rotation and its faster orbit around the sun pull these two clocks apart. The solar day, the cycle of light and dark that you would actually live through, runs to about 117 Earth days. But the time for the planet to turn once relative to the distant stars is the longer 243 Earth days. The sky has two different rhythms layered over one another, the slow procession of the stars and the even stranger crawl of the sun moving backward against them. It is as though time on Venus is written in two hands that disagree, a planet whose calendar contradicts its own clock. And think about what the slowness does to the simple matter of warmth and shadow, were it not for that all-enveloping blanket. On most worlds, a long day would mean a scorching afternoon and a freezing night, because the ground would have months to heat under the sun and months to lose that heat in the dark. Venus should, by the logic of its slow spin, be a world of unbearable extremes, baking for 2 months and freezing for 2 months. And it is not. It is uniform, the same searing heat through the endless day and the endless night alike. This is the atmosphere overruling the spin. The thick ocean of air carries and stores so much heat and moves it around the globe so thoroughly that it erases the difference the slow rotation should have created. So here we have two of the great strangenesses of Venus, The slow backward day and the crushing thick atmosphere meeting and cancelling one another in a single fact. The spin says the temperature should swing wildly. The air says it will not, and the air wins. The result is a planet where even time, even the long, slow march of day into night, is robbed of its usual power to change anything. On Venus, the day may be longer than the year, but it hardly matters to the heat. The furnace burns the same whether the sun is up or down. But step back from the mechanics for a moment and feel what the slow backward day really means. It means that on Venus, the simplest, most universal human experiences would all be strangers. The reassurance of morning, the rhythm of a single day, the comfort of watching the sun set in the familiar west and knowing it will return by morning, none of it would hold. A person standing on Venus, if such a thing were survivable, would be standing outside of human time entirely, in a place where the sun rises wrong, moves wrong, and takes a season to cross the sky, where you could live an entire earthly month, and the local day would not even be half done. There is something almost meditative in it, if you let the horror of the heat fade into the background for a moment. A world turning so slowly that its day swallows its year. A world where the light comes from the wrong side and lingers like a held breath. It is the strangeness of Venus, expressed not in temperature or pressure, but in the very flow of time. And to me, it is just as profound as the heat and the crushing air. It reminds us that the rhythms we treat as eternal, the day and the night, the direction of dawn, are not laws of the universe. They are local habits of our particular planet. Change the spin of a world, and you change the shape of time itself for anything that might live there. And that brings us, at last, to the most tender question of all. We have stood on a surface that melts metal. We have sunk beneath an ocean of crushing acid air. We have lived through a backward day longer than a year. Through all of it, Venus has seemed utterly, completely dead, the very definition of a world where nothing could survive. And on the surface, that is almost certainly true. But there is that one mild layer we spoke of, high in the clouds, where the heat relents and the pressure softens. And a few years ago, from exactly that layer, came a signal so faint and so strange that it made serious scientists ask, out loud, in the pages of respected journals, whether something might be living in the sky of Venus after all. Let us listen very carefully to that whisper. To follow this part of the story honestly, I have to ask you to hold two things at once: the wonder of a possibility and the discipline of doubt. Both belong here. The story of the search for life on Venus is not a story of discovery. It is a story of a question that will not sit still, a question that has been raised and lowered and raised again. And the most truthful thing I can do tonight is walk you through it exactly as it happened, with all its excitement and all its caution intact. Begin with the place. We are not talking about the surface now. Nothing we understand about life could survive that lead melting ground. We are talking about that one gentle layer high in the clouds, around 50 kilometers up, where the temperature settles into a range a human might call warm rather than deadly, and the pressure eases to something close to what you feel at sea level on Earth. For decades, a handful of scientists had quietly pointed at that layer and wondered, if life can cling to the harshest corners of Earth, to acid springs and boiling vents and frozen deserts, then could some hardy microbe, some tiny drifting thing, survives suspended in the temperate clouds of Venus, floating in the one part of that savage planet that is not actively trying to destroy it. It was a fringe idea, a romantic one. Most people set it gently aside. Then, in the year 2020, came the announcement that turned that fringe idea into a global headline overnight. A team of astronomers reported that they had detected a gas in the clouds of Venus. The gas was called phosphine. And to understand why its detection set the world alight, you need to understand what phosphine is and why it mattered. Phosphine is a simple molecule, one atom of phosphorus bound to 3 atoms of hydrogen. On Earth, in the conditions found at the surface of a rocky planet, phosphine is not something that just appears on its own. It is difficult to make. It takes energy and unusual chemistry to force those atoms together. And here is the crucial part, the part that made hearts race. On Earth, almost all the phosphine we find is associated with life. It is produced by certain microbes, by living things in oxygen-starved environments, in swamps and marshes and the guts of animals. It is, on our planet, very largely a product of biology. So phosphine had been proposed in advance as a possible biosignature. A biosignature is a chemical fingerprint, a substance whose presence might hint that living things are nearby because we struggle to explain how it could be there without them. So when that team announced phosphine in the clouds of Venus, in exactly the temperate layer where life had been imagined, the implication was electric. They had run the chemistry. They had tried, carefully, to think of every non-living way that phosphine could be produced on Venus. Every volcano, every lightning strike, every reaction between sunlight and the strange chemistry of those clouds. And in their analysis, none of those ordinary sources came close to producing the amount they believed they had detected. They were cautious in their language. They did not claim to have found life. They said, in effect, that they had found something they could not explain, a gas that should not be there in that quantity, and that one possible explanation, however extraordinary, was that something in those clouds was alive and making it. The world heard the careful version and the loud version at the same time. Headlines bloomed across the planet. Life on Venus, a sign of life in the clouds of our sister world. For a few shining days, it felt as though the universe had cracked open just a little, as though the answer to the oldest question, "Are we alone?" might be hiding not light years away but right next door, in the glowing planet we can see with our own eyes from the back garden. I remember the feeling. It was intoxicating. It was hope. But this is where the discipline of doubt enters, and where the story becomes, in its own way, even more interesting than the headlines. Because science does not run on excitement. Science runs on scrutiny. And the moment that claim was made, the entire community of planetary scientists did exactly what they are supposed to do. They tried to tear it apart. The detection rested on a faint signal, a tiny dip in the light gathered by radio telescopes at a particular wavelength where phosphine absorbs. And faint signals are slippery things. Other teams went back to the data, the same data and other data, and began to ask hard questions. Was the signal really phosphine, or could it be another gas entirely? Something like sulfur dioxide, which is abundant on Venus and absorbs at a nearby wavelength. masquerading as the more exciting molecule. Was the dip in the light a true feature of Venus, or could it be an artifact, a ghost produced by the complicated process of cleaning and combining the telescope data? Several reanalyses came back skeptical. Some teams reprocessed the observations and found that the signal shrank, or weakened, or vanished into the noise. Some argued that whatever was there was far smaller than first claimed, small enough that ordinary explanations might cover it. The confident detection began to wobble, and so within months, the story flipped in the public eye. The gas that had hinted at life was, many concluded, never robustly there at all. Debunked, the headlines now said. A mistake. A signal that melted under closer inspection. The dream folded back up. And if the story ended there, it would be a familiar and even comforting tale. The tale of science correcting an overexcited claim, of doubt doing its proper work and returning us safely to a dead and lifeless Venus. But the story did not end there, and this is the part that often gets lost, the part I most want you to carry away from tonight. The question did not stay closed. The original team and others went back, gathered more observations, looked again with fresh eyes and different instruments. And in the years since, some of those follow-up efforts have reported the signal once more. Newer observations have, according to the teams behind them, recovered phosphine in the clouds of Venus, sometimes in ways that seem to change with time and with the cycle of day and night, as though the gas is being destroyed by sunlight and then somehow replenished from below. Around the same time, a second tentative claim emerged, this one of ammonia, another gas that is hard to explain on Venus and that, like phosphine, is tied on Earth to biological and chemical processes that hint at unusual conditions. Two strange gases now, not one, each difficult to account for, each cautiously reported in that same temperate cloud layer. So where does that leave us? Honestly, tonight, it leaves us exactly in the uncomfortable electric middle. Not at discovery, not at dismissal. In between, where real science so often lives. The truthful summary is this: the detections are contested. Some scientists believe the phosphine signal is real and persistent. Others remain unconvinced that it is there at all, or argue that even if it is, the amounts are small enough to leave room for non-living explanations we have not yet pinned down. And crucially, even among those who accept that the gas is real, very few would leap to life as the answer, because here is the sober heart of the matter. We do not fully understand the chemistry of Venus. That cloud layer is an alien environment, drenched in acid, lit by harsh ultraviolet, churning with reactions we have barely begun to map. It is entirely possible that there is some ordinary, non-living source of phosphine or ammonia on Venus that we simply have not thought of yet. Some quirk of volcanism or photochemistry or acid cloud reaction that our earthbound intuition has missed. Detecting a hard-to-explain gas does not mean detecting life. It means detecting a mystery. And that is exactly the right way to hold it. A biosignature is not proof. It is a question that demands more questions. The presence of phosphine, if it is truly there, tells us that something on Venus is doing chemistry we do not understand. That alone is thrilling. It would be thrilling even if the answer turns out to be some exotic mineral or volcanic process and not a single living cell. Because either way, it means there is something happening in the clouds of our sister world that breaks our current understanding. And breaking our understanding is how every real discovery begins. I want to pause here and honor what this whole episode reveals about how science actually works. Because it is easy to come away from a story like this feeling that science failed, that it announced something and then took it back, that it cannot make up its mind. I would ask you to see it the opposite way. What you are watching, in the rise and fall and rise again of the phosphine claim, is science working exactly as it should. A bold observation is made. It is shared openly. The whole community pounces on it, not out of cruelty, but out of rigor, testing it from every angle, trying their hardest to break it. Some of those tests seem to break it. The original team does not simply give up. They gather more data, refine their methods, look again. The claim is neither blindly accepted nor permanently buried. It is held in tension, examined, argued over, slowly refined. This is not failure. This is the immune system of knowledge doing its work. The messiness you are seeing is not a flaw in the process. It is the process. And the fact that the question remains genuinely open years later is not a sign that no one is competent. It is a sign that the question is hard, and that the people working on it are being honest about how hard it is. Consider too why Venus is such a difficult place to read from a distance. Everything we know about that cloud layer we have to gather across tens of millions of kilometers by collecting the faint light that passes through or reflects off the planet and teasing apart the signatures of different gases hidden within it. It is a little like trying to identify the ingredients in a soup by standing across a crowded room and studying the steam. The strongest signals, the most abundant gases, the carbon dioxide and the sulfur compounds, shout over everything else. A trace gas like phosphine, if it is there at all, is a whisper beneath that roar. And whispers are exactly the kind of thing that can be imagined when they are not there, or missed when they are. This is why the only real way to settle it is to stop listening from across the room and to walk into the kitchen, to send a probe directly into those clouds and let it taste the air molecule by molecule, with no tens of millions of kilometers of distance and noise in between. Until we do that, the whisper will remain a whisper, and honest people will keep disagreeing about whether they truly heard it. I want to be very clear and very fair, because this topic invites exaggeration in both directions. There is, as of now, no confirmed evidence of life on Venus. None. Anyone who tells you we have found aliens in the clouds is far ahead of the data. But it is equally wrong to say the question has been settled and closed, that phosphine was simply a mistake and there is nothing more to see. The honest position, the one held by most careful scientists, is that the clouds of Venus contain at least one and possibly two gases that are genuinely hard to explain, that the measurements remain disputed, and that the only way to truly know is to go back and look more closely, on the spot, with instruments designed for exactly this question. And that is precisely what we are now preparing to do. The phosphine debate, whatever its final resolution, did something valuable. It reawakened the world's interest in a planet we had largely ignored for a generation. It reminded us that the most hostile world in the solar system still has a soft and temperate layer we have barely studied, a place where the impossible question of life refuses to fully die. After decades of looking outward to Mars and the distant moons of the giant planets, The faint whisper of phosphine turned our attention back to the bright light next door and asked us, gently but insistently, to come and listen more carefully. It is worth pausing to ask why this particular question, the question of life on Venus, grips us as strongly as it does, far more strongly than the planet's heat or pressure ever could. I think it is because the search for life elsewhere is really the search for an answer to our deepest loneliness. We have looked up at the sky for as long as we have been human and wondered whether we are the only ones. Whether life is a once-in-a-universe accident or something that arises wherever conditions allow. If life were found in the clouds of Venus, on a world right beside us, born of the same dust, then the answer would tilt powerfully toward the second possibility. It would suggest that life is not a fluke but a tendency, something the universe does readily given half a chance. That is why a faint dip in a radio signal could make headlines across the entire planet. It was never really about phosphine. It was about whether we are alone. And that is a question worth being careful with, worth refusing to answer until the evidence is truly overwhelming, because the temptation to believe is so strong that it can lead even careful minds astray. The discipline of doubt is not coldness, it is respect. Respect for a question so important that it deserves to be answered correctly rather than quickly. So we will. New missions are being built right now to return to Venus, to fly through those very clouds and sample the air directly, to finally measure what is and is not floating in that temperate layer, to settle the question of phosphine and ammonia, not with distant telescopes straining at faint signals, but with instruments breathing the actual atmosphere of Venus. We will come back to those missions in a moment. But first I want to let the wonder of this settle without rushing to resolve it. Somewhere high in the clouds of the most hostile planet we know, suspended in a thin band of almost gentle air above an inferno that would destroy anything below, there may be a chemistry we do not understand. It may be exotic geology, it may be a trick of our instruments, or it may, just possibly, be the faint exhalation of something alive. We do not know, and the not knowing, held honestly, is one of the most beautiful feelings in all of science. It is the feeling of standing at the edge of a question too big to close. Let that feeling carry us into the final part of our journey, where Venus stops being only a strange and distant curiosity and becomes something closer to a mirror, because the deepest reason to understand this ruined twin is not only to learn about Venus, it is to learn about ourselves and about the fragile, temporary, almost miraculous conditions that make our own warm world possible. We have come a long way together tonight. We began with a bright and gentle light in the evening sky, a planet we once dreamed held oceans and jungles. We found instead a surface hot enough to melt lead, an ocean of air heavy enough to crush a submarine, clouds of acid that rain, a rain which never lands, a day longer than a year, a sun that rises in the west, and a faint, disputed whisper that may or may not be a sign of life. Now, at the end, I want to gather all of it into a single thought, the thought that gives this whole strange journey its weight. Venus is a mirror, and what it reflects, if we are brave enough to look, is a possible future of our own world. Let me return to that idea of the runaway greenhouse, the slow catastrophe that may have turned a young, watery Venus into the furnace we see today. The reason that story matters so deeply is that the physics behind it is not unique to Venus. It is the same physics that operates on Earth, the same trapping of heat by carbon dioxide, the same feedback between warmth and water vapor, the same delicate balance between how much sunlight a world absorbs and how much heat it can let go. Venus is not a different kind of place running on different laws. It is the same kind of place as Earth, a rocky planet with an atmosphere that happened to tip past a threshold we did not. And here I want to be careful and precise, because this comparison is often stretched too far in both directions. The runaway that destroyed Venus happened over enormous spans of time, billions of years ago, driven primarily by its position closer to the Sun and the slow, relentless brightening of our star. It was a natural process on a deep cosmic timescale. It is not the same thing as the changes our own world is experiencing now in our own short era, which have their own distinct causes and their own distinct science. I am not telling you that Earth is about to become Venus. It is not. Our planet is far from that edge, and the differences between the two worlds are real and significant. So let me set that worry gently to one side. Venus is not a prophecy of next century. What Venus is a proof. A proof written across an entire planet that the comfortable, life-giving balance of a world is not guaranteed, that a planet can lose it, that the line between a paradise and an inferno is thinner and more fragile than our instincts ever told us. Think about what that means. For most of human history, we treated the climate of our world as a fixed backdrop, as permanent and unchangeable as the ground itself. The seasons would always turn. The oceans would always roll. The air would always be breathable, and the temperature always survivable. It simply was the way the world was. But Venus tells us that none of this is automatic. Right next door, on a planet that began with the same ingredients as ours, the backdrop did change. The oceans did vanish. The breathable air did become a crushing poison. The survivable temperature did climb past every limit. A whole world's gentle balance was lost completely and permanently. And it is still lost today, and it will stay lost for as long as Venus exists. That is the lesson of the mirror. Habitability is not a property a planet simply has. It is a balance a planet holds, and balances can be lost, and there is a longer, slower truth folded into this as well, one that has nothing to do with us, and everything to do with time itself. Our sun is slowly, steadily growing brighter, not in a way you could ever notice in a human lifetime, or even across all of recorded history, but across the vast stretches of deep time, hundreds of millions and billions of years, the sun is gradually increasing its output. And on that immense timescale, far, far beyond any concern of our own age, the slow brightening of the sun means that Earth too will one day face the same pressures that overwhelmed Venus. Billions of years from now, long after everything we know, our own oceans may face the same fate, evaporating into a thickening sky as the aging sun bears down. In the deepest future, Earth may follow Venus into the runaway. Venus, in this sense, is not only our sister. It may be a glimpse of our planet's final chapter, separated from us by an ocean of time so wide we can barely conceive of it. There is no fear in that thought, only a kind of vast and humbling perspective. We live in the brief, precious, temperate spring of our world, in the narrow window when the sun is gentle enough and the balance holds. Venus reminds us how rare and how fleeting, on the scale of the cosmos, such a window truly is. There is a humility in this that I find steadying rather than frightening, and I want to dwell on it for a moment before we turn to the future. For most of human history, we have placed ourselves, quietly, at the center of things. We assumed our world was permanent, our conditions normal, our comfort the natural state of a planet. Venus dismantles that assumption with a single glance. Here is a world that did everything Earth did, started where Earth started, and ended in fire. It tells us that we are not at the center of some guaranteed stability. We are guests in a narrow band of good fortune on one particular world that happened to keep its water and hold its balance. To know that is not to be diminished. It is to be invited into a deeper kind of gratitude, the gratitude of someone who realizes how easily things could have gone otherwise, and chooses to cherish what is. And there is a strange companionship in Venus too, if you sit with it long enough. We so often imagine that to find a planet truly like Earth, we must look far across the galaxy, to distant stars and the faint specks of worlds we may never reach. But the most Earth-like planet in size and composition, the nearest sibling our world has been hanging in our own evening sky the entire time. It is not a comfortable sibling. It took the dark path. But it is family, and studying it teaches us things about Earth that Earth alone could never show us. By understanding how Venus lost its oceans, we understand better how Earth kept its own. By tracing how a temperate young world became a furnace, we learn to read the warning signs and the safeguards in our own atmosphere. Venus is the control group in the grandest experiment imaginable, the experiment of how a rocky planet lives or dies. We could not have designed a more instructive neighbor if we had tried. This is why, after decades of looking elsewhere, we are returning to Venus now. For a long time, our sister world was neglected, written off as a dead furnace not worth the trouble, while our robots roamed Mars and our telescopes reached for distant stars. But the phosphine debate, the deep questions about the runaway greenhouse, the realization that Venus holds answers about how rocky worlds live and die, all of it has pulled our attention home. A new generation of missions is being prepared to fly to Venus in the years ahead. One will plunge a probe directly through the atmosphere, breathing in the air layer by layer as it descends, measuring exactly what those clouds and that thick sky are truly made of, finally putting the phosphine question to a direct test. Others will map the surface in unprecedented detail from orbit, peering through the clouds to study the volcanoes and the strange geology and the history written in the rock, searching for clues about whether Venus ever truly had oceans, and when and how it lost them. We are going back to read the rest of the story. We are going back to learn how a twin becomes a stranger, because that knowledge is, in the end, knowledge about the fate of worlds like our own. Let me tell you a little more about what those returning missions hope to do, because there is real wonder in the plan. One of them is designed to drop a probe straight down through the atmosphere, and as it falls, it will breathe. Layer by layer, kilometer by kilometer, it will draw in the air around it and analyze it, building the most detailed chemical portrait of the Venusian sky we have ever had. It will fall through the temperate cloud layer where the phosphine question lives, sampling exactly the air that has caused so much debate, and it may finally tell us directly and on the spot, what is truly floating there. As it descends into the deeper, hotter, clearer air below the clouds, it will keep measuring all the way down toward that ancient volcanic surface, sending home a stream of data from a place we have touched only a handful of times in all of history. And from orbit, other missions will use radar and infrared eyes to peer through the clouds and map the surface in detail far beyond anything we have, searching the rock itself for the fingerprints of Venus's past, for the old shorelines of vanished oceans, for the signs of how and when this world fell. What we are really doing with all of these missions is going back to ask the planet to finish telling us its story. We know the ending, we have seen the furnace. What we do not yet fully know is the beginning and the middle. Did Venus truly have oceans, and for how long? When exactly did the runaway begin, and what tipped it over the edge? Is the planet still volcanically alive today, still reshaping itself beneath the clouds? And in that one temperate layer, against all expectation, is there any chemistry we cannot explain by rock and light alone? These are the questions waiting in the dim, orange dark, and within our lifetimes we may begin to answer them. The bright light in your evening sky is about to become, once again, a place we are actively exploring. And so we arrive, gently, at the end of our journey, and I want to bring you all the way back from that distant glowing world to exactly where you are right now. Because everything we have seen tonight is, in the end, a way of seeing home more clearly. Take a slow breath wherever you are. Feel the air move easily into your body. That air is a soft and breathable mix, not a crushing ocean of acid. Feel the temperature around you, mild enough that your body barely has to think about it, not a heat that would melt the metal in the room. Notice, if it is night where you are, the simple miracle that the darkness is cool, that the heat of the day has gently let go, that tomorrow the sun will rise where it always rises, in the east, the right way. After a night that lasts hours and not months. None of that is guaranteed by the universe. We know that now because we have looked at Venus. On our sister world, the air would crush you and burn you and poison you all at once. The night would not cool. The sun would rise backward and take a season to cross the sky. And yet here, on this one quiet world, the balance holds. The air is kind, the night is cool, the day returns on time. You are held right now in the narrow and beautiful margin where a planet stays gentle, the same margin that Venus once may have had and lost forever. There is something worth carrying into sleep in that. Not fear, but gratitude, and a kind of expanded tenderness for the ordinary comfort of your own world. The next time you see that brilliant point of light low in the evening sky, that bright, steady jewel that is the first to appear after sunset, you will know what it truly is. Not a star, a world, our twin. A planet almost exactly our size, born beside us from the same dust, that took a different path and became the most hostile place we know. And you will know that the soft air around you, the cool of your night, the simple promise of an ordinary dawn are not nothing, they are everything. They are the rare and fragile balance that made you possible. So rest easy tonight, held by a world that, against all the odds of the cosmos, stayed gentle. Let the strangeness of Venus drift through your mind like a slow dream, the acid clouds and the backward sun and the day that outlasts the year, and let it settle not into worry but into wonder. Out there, our sister burns in silence beneath her beautiful veil, and here you breathe, and you are warm, and you are safe. Sleep well. The dawn will come in the east, the way it always has.